Okay, so let's look at this first problem here. And we're looking at a regular hexagon. So of course that has 6 vertices. And we're looking at rotations. This is the smallest rotation in the symmetry group, rotation by 60 degrees. And S is a reflection of H, which leaves vertex A fixed. So let me just go ahead and draw the hexagon for reference. It's got 6 sides. So I'll start here at 0 degrees. Oops, sorry. I think what I have to do is do this again. Okay. So at 0 degrees, then at 60 degrees, then at next one, sorry. Keeps doing that. I don't know why. You have to do it, just do a dot. Okay. And then here's one here. 1, 2, 3. So here's my hexagon. A, B, C, D, E, F. Good to have reference. A lot of people did draw the hexagon, which is a good thing. Now, of course, S leaves A fixed. So let's see. So how many elements are there in the symmetry group of H? Now, this is a regular polygon with 6 sides. So H, so the symmetry group, of H is equal to D6. Dihedral group with on 6 vertices, which has, and the order of D6 is 12. So the answer of this one would be 12. Okay. Part B, write all the rotations in Tableau notation. All right, so in Tableau notation, we know the first row is going to be A, B, C, D, E. 1, 2, 3, 4, 5, 6, F. All right, now, the first rotation would be 60 degrees, and that means A goes to B, B goes to C, C goes to D, E, F, and F goes to A. That would be the first one. Second one, A, B, C, D, E, F. Second row, in this case, A goes to C. And then each subsequent vertex goes to the subsequent vertex in the list. So that's C, D, E, F, A, B. Next one is A, B, C, D, E, F. And then here we have, instead of it going to C, it goes to D, E, F, A, B, C. And I'm not going to write them out, but there's 6 altogether. And if you do it this way, then the last one would be identity. So the last one would just be A, B, C, D, E, F, which counts as a 0 degree rotation. All right, write the reflections of the symmetry group in cycle notation. All right, so we're looking at cycle notation. That's a different deal. First, let's look at S. Now, what does S do? S leaves A fixed. If it leaves A fixed, think about what the axis of the flip is. The axis would go through AD. So in fact, that would mean, if you flip over this axis, that means B and F exchange, C and E exchange. So S is equal to BF, it's a B, sorry. It's equal to BF, CE. Now, we have more flips. We can flip across this axis BE. If we flip across the axis BE, then A and C exchange, and so do D and F. Or we could flip across the axis CF, in which case B and D exchange, and so do A and E. Okay, but that's 3 flips, and we know that D6 has 6 flips. So what are the other flips? Well, the other flips would be the ones between vertices, like between AB and DC. If you draw the axis there, that splits those 2 sides. Then A and B exchange, C and F exchange, D and E exchange. So that would be A and B exchange, C and F exchange, and DE exchange. That's an F, sorry. All right, then there's another one which splits the segment between BC and EF, so that's going to be CB exchange, EF exchange and AD exchange. Actually, you should write the AD first. I have been a little sloppy about that, but it really doesn't matter because all these cycles commute. And then there's one more between the C and D, in which case you'd have CD exchange, and then you'd have B and E exchange, and you'd also have AF exchange. All right, so cycles are very different from tableaus. They follow a different set of rules. All right, let's go on to question 2. Question 2 says, what are the possible cycle structures of elements of the symmetry group of H? Okay, now we have 12 elements, and we need to look at the cycle structures. So for part A, if we just look at the flips or reflections, we see from part 1 either product of 2 cycles, product of 2 cycles, or product of 3 2 cycles, or we could call them transpositions. It's either product of 2 transpositions or product of 3 transpositions. So the structures here are 2 2 cycles or 2 2 2, 3 2 cycles. We also have rotations. Now, one rotation is going to be a 6 cycle. That's the rotation 60 degrees. Now, if you rotate 120 degrees, what happens? Well, if you follow it along, if you rotate this 120 degrees, the A goes to C. Here, let me do this. The A will go to C. The C will go to E. The E goes to A. That's actually a 3 cycle. And there's another 3 cycle with B goes to D, D goes to F, F goes to B. So that's actually 2 3 cycles for 120 degrees. Okay. So that's another possibility. So that would be 3 3. And then let's see. Let's take a look at the other one that takes A to D. If A goes to D, then that's actually, let's see. Oh, where's my thing here? If A goes to D, then that means that E goes to B, C goes to F, and they also reflect. So that's also going to be a 2 2 2. That's another 2 2 2, because all of those are 2 cycles. It's not a reflection, but it's still a 2 2 2. So this is going to be or 2 2 2. Okay. Okay. Now you wouldn't have to denote the cycles this way. This means 2 2 cycles, 3 2 cycles, etc. Okay. Where A, B, C means an A cycle, a B cycle, a C cycle, etc. All right. Now we also have the identity. Okay. So I should say or ID. ID is no cycles, so you can just leave that separate. All right. So let's look at B. What are the orders? So B you get from A. All right, let's see. I'm having trouble finding my mouse. B. So the orders are the LCMs of cycle lengths. Okay. So in the first case with 2 2 or 2 2 2, you'd have either 2, and then this one, this 2 2 2 also has order 2. This 6 cycle has order 6, and this product of 3 cycles, the LCM is 3, so we have 3 6 2 and ID. Let's see. So then here, let's say and ID. So in that case, really, if you follow this definition for ID, you'd have a 1. All right. So the answer, let me just box the answers. So this answer would be this. Okay. Now let's go to C. Find all elements of the symmetry group that leave C fixed and express them in cycle notation. So if you go back to the first problem, you'll find that none of the rotations leave any vertices fixed because you're moving everything when you rotate. So the only symmetry that leaves C fixed is the one that is the reflection across the axis involving C. So you just go back to part 1 and look at this. Which one doesn't involve C? And that's this one, BDAE. That's the only one. This is the only one that doesn't move C. So actually you should write the AE and BD first because the AE has the A in it, but it really doesn't matter all that much. So this would just be AE and BD. Okay, so that's the answer for part C.